Hello, friends. Today we're going to start with part 3 of the 2019 state biology test. Our first one up is labeled question 15. The cladogram shows evolutionary relationship among 7 organisms. Which grouping of organisms include an ancestor and all of its descendants? What we are looking for here is a clade. So let's look at A. MNO. M-N-O. Well, I don't see no common ancestor and all of its descendants. Let's skip B. Let's look at C. O-P-R. O-P-R. Oh, no common ancestor there. D. P-R-S. P-R-S. Again, no common ancestor. It's close. But when we look at N-O-P, N-O-P, a common ancestor and all of its descendants, that's our clade, and that be the correct answer. Next, we'll look at question number 16. I'm not going to read you the instructions. I'm just going to explain it to you. So we have a chart here. It has original DNA. And then we have the original amino acid change from the DNA. Remember, we go from DNA to RNA to protein. And protein is made up of amino acids. Now, what's supposed to have happened here is a mutation. Now, we need to figure out, was that mutation a deletion? Was something removed from our chain? Was there an insertion? Was something put in there as extra? Or was there a substitution? Okay. So let's look. Now, remember, our DNA has to give the code to the RNA. So TAC would be AUG, and that would give us the amino acid MET. So let's look that up. So our AUG, okay, that would be our amino acid, would be A, U, and G. Remember, first letter, second letter, and third letter. So that works out good, okay? We're looking at 2 because everything is the same in mutant 2 as there is in the original chain except for the TRP. So what was our original RNA? Our original RNA would be UGC, okay? So let's look up UGC. U, G, and C, CYS, okay? And that's how we get the original. But how did we get the TRP? Well, let's look over here. There's TRP, U, G, A. Oh, so what's happening is, since everything else is the same, okay, then what happened was we had a substitution, and therefore nothing else changed except for this one amino acid. Now let's look at mutant 1. Now in our instruction, it tells us that we have to use all of these at least once, okay, just once. So here we go. Same thing here where this is changed from the CYS to the TRP, okay? Remember, our original is UGC, but then it became UGG. So if it is an insertion, that means our C moved over to the next part of the chain. So in this case, we have a C, and we would only use these next 2 letters. So it would be C-A-G. So let's look up C-A-G, C-A-G, and we get the G-I-N, all. So what's happening is, because there has been an insertion, then that affected the rest of the chain. And since we have to use all 3 of them, the final one is a deletion. Okay, and you can see it's shortened. So, kind of a tricky problem, one you guys spend a little time on, but not hard. Number 18. Question number 18. Scientists observed that 4 desert lizard species eat insects as part of their diet. The table shows the percentage of each lizard's diet that are made up of different insects. So we look at our chart here. We have lizards M, N, O, and P. We look at M. That guy likes everything except the ants. N, he eats everything except the termites. O, He's eating everything except the ants, and P really likes the ants and the beetles, but nothing else. Which statement could explain the dietary specialization of lizard species P? Well, let's look at A. Lizard P has more genetic variability than lizards M, N, and O. This is incorrect. Dietary specialization alone does not necessarily correlate to genetic variability. Let's look at answer C. Each lizard chose to have adaptations that allow them to exploit different resources. Lizards can't choose their adaptation. D. Ants have a smaller population than locust, beetle, termite, and larvae populations. This is incorrect. The size of the population does not drive an organism to be more dependent on it as a resource for food. The correct answer is B. The reason B is the answer is because populations of organisms can experience subtle changes in phenotypes and behavior when they are living in different niches within an ecosystem. That is our last problem for part 3 of 2019. Thank you for participating.